Sonic, the heart of your system.
Hi and welcome back to a new video. Exactly 1 week ago we were allowed to publish data about the RTX 3080 and now it's time for the RTX 3090. 24GB, 20% more CUDA cores, slightly higher TDP, 350 instead of 320 watt. That should be absolutely interesting. We have a Gigabyte gaming OC card on this table, which we are going to dismantle today. We're going to remove the cooler, check out the PCB, check out the cooling capacity, like RPM and what kind of noise we can expect, temperatures, maybe a little bit of OC, and in the end also check if we're moving to a water cooler. I'm planning to somehow, I don't have a water block yet, but I'm planning to somehow mount a water cooler on there. And then we can maybe drop the temperature, let's say from 60 to 45 degrees Celsius, and then we can maybe figure out if we can expect higher clocks by dropping the temperatures on those cards, because that's usually what you're getting if you move to water cooling, maybe like 40 degrees Celsius max under load if you have a very strong cooling loop, and then maybe we can gain performance, gain boost clock. Let's see how this works out. First look is great. We have a plastic shroud. Unfortunately, I'm more a friend of metallic optics, let's say aluminum shroud, but even though this is a plastic shroud, the card still looks very, very high quality. We have 3 fans in total. 2 are spinning counterclockwise, the one on the left and the one on the right. You can always spot that by the orientation of the fans. Center one is spinning clockwise. As I said, visually I would have preferred if this would be metal, but otherwise looks still, yeah, very high quality, this card. Quick look from the side, we can spot all the open holes which are necessary for the ventilations, because it's a top blower card. The hot air will exit here from the side. We have a GeForce RTX logo which is stuck on the backplate. The top part right here is already part of the backplate. We have a Gigabyte logo on the bottom, probably RGB. We will check that in a second once the card is sitting inside the system. And we have 2 8-pin connectors in the back. I absolutely prefer that over the new 12-pin connector on the Founders Edition. Here's the impression from the back, and yeah, the first thing I'm spotting is this sticker on the back. I'm not a fan of this placement. Like, this is the side you would see inside your system. If you put it normally in your main board, then you would always see the backplate, right? And then having the sticker on here in this very nicely designed card, not a fan of the placement. Would be better on the PCB or on the side, maybe here on the cooler. Of the fan which is sitting underneath can blow right through the cooler, exit right here with the hot air, and underneath there we can see some cables, and that's because those 2 8-pin connectors are extended from the PCB over wires directly to the back, but we will see that in a second once we remove the backplate. Otherwise, nice design. Time to check out the cooler from underneath. Something I always like about the Gigabyte designs is how they make use of the space between the block and the card. Or, I mean, they just make the most out of the block. Somebody's demanding cuddles. Alright, you can see all those small cutouts within the fins, and that is to maximize surface area for the cooling block, something I like. That's something Gigabyte is always doing. Then we have a massive copper plate right here, and this copper plate is connected to 5 heat pipes which are going to the left and 2 additional heat pipes which are going right. Means we have 7 heat pipes in total, and everything is just one part. Everything is cooled at once. Memory ICs, we have cooling for the MOSFETs, for the inductors on the left, and again inductors and MOSFETs also on the right. Now a closer look at the PCB, the voltage supply and everything that comes with it. In total we have 18 phases on this thing. Again, you see some of the inductors marked with an M. That's why I did the measurements to check out which of those phases are doing exactly what, because it's also interesting on those RTX 3080, 3090 cards how they organized the phases. We have 18 phases in total on this card, and 4 of those phases, this one, the one right here on top, and the one on the bottom, those are for memory voltage supply, and all the other 14 phases are for GPU voltage supply. Again, we have a ton of shunt resistors sitting right here. I still have to investigate those in detail to see which of those are exactly doing what. Those two are obviously the input shunt resistors to measure the power consumption going through the two 8-pin connectors. And then there's another one sitting right underneath here on the back side, and that one is checking the power consumption coming through the PCI Express slot. And then all the others are probably just to split up the measurement between like memory power supply and then GPU power supply. But again, we will have to investigate this further. The voltage controller is the UP9512, again the same as on the ASUS RTX 3080 TUF and also the same as on RTX 2080 Ti. And here, as I showed you in the beginning, the two 8-pin connectors going through some additional wires to those connectors right here, and those are not standard 8-pin connectors. This is not just an extension, they have completely separate special connectors sitting on here. This is also not the 12-pin NVIDIA connector. And that's how those energy connectors or power connectors look like after removal from the PCB. Definitely not a standard connector you have somewhere in your PC. Without even having tested this card, I'm asking myself why they decided to go for this strange connection solution. Just thinking about water cooling solutions, I don't see how you would mount a water cooling block on there. I mean, obviously you can do that. Then you have to remove the extension from the back plate, attach the extension to those connectors right here, and then have it hanging off like this, and then attach your normal 8-pin connectors, but you wouldn't be able to have a nice clean sleeved solution with this. But that's only just a concern if you're a water cooling guy and if you're trying to get RTX 3090 just for air cooling, and you know for a fact that you're never going to change to water cooling. I'm not even sure if there are blocks which exist for this card, but if you know for a fact that you will stick with air cooling, this is not a concern, then this is actually even good, because then you don't have the connector sitting somewhere in the middle where you have to route your cable directly over your GPU. Then you have it sitting right at the end of the card, which is more convenient for connecting. Therefore, it's positive for just air cooling, but would be negative if you're ever planning to go for water cooling. Nothing spectacular on the back side, just a ton of memory sitting in the middle on the bottom right next to the PCI Express connector. We have the shunt resistor measuring the power consumption coming from this. By the way, this should also be the first time that the mounting holes, like the general mounting holes, come in a rectangular shape. Previously it was always a square shape, and now the dimension is, this one is 58.5 millimeters and this is 67.5 millimeters, just in case anyone is interested for cooler design or whatever. And before I start reassembling the card, there is also a BIOS switch right here which allows switching between an OC profile and a silent profile. Probably only difference is clock and the fan curve. Card is running. We'll say silent in between so you can get an idea or an impression of the noise level. Currently running at 1800 and 1900 RPM, those fans, with a temperature of about 65 degrees Celsius. Keep in mind that I'm running an open test bench and I have a room temperature of about 24 degrees Celsius. If you would put this in a closed system with very bad ventilation, you would definitely be able to hear this card. In my case, running times by extreme at 1440p in windowed mode and also looped mode, boost wise, performance wise, somewhere always in the region of 1800 megahertz, sometimes dropping a little bit below, but I also saw up to 1845 megahertz in boost. Temperature wise, pretty cold with 64 degrees Celsius. There's definitely some headroom in cooling, and also again fan speed running at about 1800 RPM on fan speed 1 and 1900 RPM at fan speed 2. Just switched to the silent profile and I think I like this one more. You can see a change in fan speed 1 and 2. It dropped down to 1500 RPM and I can definitely hear the difference, like 300 RPM less. That's something you can absolutely hear. GPU temperature is obviously higher, increased from 64 to 70 or 71 degrees Celsius. GPU boost dropped slightly, I would say by 20, maybe 30 megahertz, but not that much, something you probably wouldn't notice. And I think the trade-off is fair. A little bit higher GPU temperature, but definitely more enjoyable. And before we start disassembling this thing again for water cooling, I have to make a small complaint. Look at this connector. and because I think you can see it moving inside there with the screwdriver, and the reason for that is, I mean, this is a normal connector with a cable behind. It's not a connector that is soldered to the PCB and is solid. And you probably, or you surely all know those 4-pin Molex connectors, I don't know, from like fan connectors, water cooling stuff, pumps, and you're trying to hammer in your PSU connector into this 4-pin Molex and it just doesn't work because this 4-pin Molex is just pointed in all directions, and that's exactly what just happened to me when I tried to connect the card, like the back connector, to the 8-pin PCI Express connector. I just couldn't plug the connector in, and that was a little bit annoying. And in general, I'm not sure how smart this design is. On the RTX 30 series, most of the cards are utilizing this whole backspace with like free airflow, where the last fan can push air through the back of the cooler, but here 50% of this space is blocked with the connector and all the cables which are sitting underneath. It's only this very tiny space in the bottom which can be used for the airflow, for this, they call it screen cooling, but everything on top is blocked by the cables and the connectors. I'm not sure how smart this design is. I think there are more disadvantages than advantages using this design. I think, yeah, it would have been smarter to leave the connectors in the middle, even though it would look ugly routing them somewhere over the card, but cooling wise and also connection wise would have been better. Yeah, sorry, I kept thinking about those cables and I just had to remove them for a quick check. As you can see, now you can clearly see through the back part of the GPU cooler. Same situation as before, about 50 RPM less than before. Not a huge impact. It definitely makes a difference, but it's not that huge. Of course, keep in mind, we removed the connecting part, like this part, from this area, and all the cables, like those cables were sitting underneath here. We have airflow now here at this point, but there's still plenty of metal blocking the airflow. I think if this would also just be one big cutout, it would definitely help and probably be another 50 RPM less. I told you at the beginning of the video that I'm asking myself if the new architecture will scale with cold, or if it's not going to do anything if we mount water cooling blocks on this. Yeah, I don't have a custom water cooling block for this card. That will be a challenge. But the thing is, I have an EK thermosphere laying around here that is a universal GPU block. However, as I mentioned earlier, back then everything was using square and now it's rectangular shape. If I put the EK thermosphere on there, you see the top holes can be aligned, that's fine. But the bottom ones, yeah, that would be a short circuit. Thermal paste is applied, and I also removed the standoffs from the mounting frame, the bottom ones. We will be able to use the top screws, those two, but you will certainly agree that just the top screws, top two, won't be enough for mounting on this card, and I can already tell you, you have to be really, really strong now. Luckily, I still have some universal mountings. I have to use two of those because they're a little bit too tiny and don't reach the middle. Yeah, obviously using the rubber part on the back, otherwise it would be a good night sweet graphics card. Let's see. And setup is ready to go. Everything is assembled. Also found good use for the EK thermosphere packaging, holding the GPU in place so there's no force from those calipers onto the GPU. Yeah, let's see if it works. And we have display signal, perfect. Idle temperature is a dream, 27 degrees Celsius. I mean, there's no load, but still. I also decided to add some additional temperature probes. This one is going to the back side of the right row of MOSFETs. Then I have an additional one measuring the back side of the left row of MOSFETs. And temperature-wise, both are very close to 40 degrees Celsius. In case you were wondering if it's an issue running a card open like this without any airflow or any cooling on like MOSFETs and memory ICs, right now, especially in idle, no issue whatsoever. Load will be a different scenarios, but I'm going to add some fans in front of the MOSFETs. 15 to 20 minutes in times by extreme loop test. 49 to 50 degrees Celsius, always steady on the GPU. GPU clock pretty much the same, about 1800 megahertz. VRM temperature is looking great. 50 degrees Celsius roughly on the left side, 65 degrees roughly on the right side. Considering that I only have a small fan on the left pointed towards the VRM and a bigger fan on the right, that is not bad at all. Just shows that the components of the VRM on this card are definitely solid. And here we have the max stable OC for this card. Somewhere between 1900 and 1950 about, yeah, that is the region this card can achieve stable with manual OC. Increased the power limit, the max I can do on this card is 105% TDP, and also increased the GPU voltage, at least in the software. Not sure if it really did anything. Alright, how much did the water cooler help in the end? It's almost nothing. It almost helped nothing. If I compare the maximum stable OC with the stock cooler versus maximum stable OC with water cooling, it's 20 to 30 megahertz in peak clock, but there's certainly a difference in performance. We can look at the data of times by extreme GT1. Just stock, the card is at 63.88 FPS. If we mount the water cooling block, you can get an increase of about 1 FPS. If you perform a manual overclock with the stock cooler, you're at about 66.8 FPS. And if you perform overclocking with the water block, you can get an increase at 68.5 FPS. But in total, we're talking about an increase between 1 and like 5%. It's almost nothing. And the even difference from the stock cooler to water cooling is almost nothing. It kind of confirms my initial feeling about this architecture and those GPUs, that they're running very much on the limit, which is not a negative thing. Because if we would have an overclocking headroom of 500 megahertz, there would certainly be something wrong with the BIOS. And in this case, the cards are performing extremely well on stock. And that is, for the average consumer, certainly a good thing. For us overclocking enthusiasts, not that great, not much we can do. Even with water cooling, I would tell you that you should not expect too much. One thing I didn't do was memory overclocking, because I don't have a full cover water block and the memory is getting a little bit warm. And that's why I think if you would mount a custom water cooling block that covers everything, you can probably get a little bit more performance out of this thing, just by also increasing the memory speed. In general, the Gigabyte Gaming OC version, I have a little bit mixed feelings about the design. The PCB itself is fine. Talking about the Gigabyte Gaming OC card in general, I have a bit mixed feelings. The PCB is great. VRM components are awesome. You could see the temperatures even just pointing a fan towards the VRM. We had like 50, 60 degrees Celsius. If you put a custom water cooling block on there, you will have great temperatures. Even with the stock cooler, I'm sure you have great VRM temperatures, no concern there. But I'm not happy with the power connector design, simply because it will make it almost impossible to have a beautiful version with a water cooling block, like a custom water cooling block. I don't even see how any manufacturer would decide to offer a water cooling block for this design, simply because of this weird power connector. And then you have the power connector and the cables blocking 50% of the airflow of the, I'm not sure how this cutout part in the backside of the cooler is called, but you know what I mean. And that is certainly not the best decision. They're blocking a little bit of the airflow. Could be better. You would have better temps or lower RPM on the cooler. The cooler itself is fine. It's not noisy. It's okay to use. If you just want to get a cheap card, like a cheap 3090, this card certainly is fine. PCB and the quality, everything is fine. Could have been a little bit better, but yeah, overall it's quite okay. Thanks for tuning in and see you next time. Bye.